everybody. In this last video on fractions, we're going to talk about fractions in equations. And I know we've seen it a little bit, but I want to show you a trick today on how to cancel those fractions out rather than trying to work with them. Because as we've seen, fractions can get pretty complicated, right? For adding and subtracting, we need common denominators. But dividing, we're flipping. So there's really a lot going on. So I have a strategy that I want to show you today on how we can solve fraction equations by canceling the fractions out. And again, this is just one strategy. So if you prefer to work with the fractions, then that is totally fine too. So I'm going to show you how to get rid of them because I think that's what most people end up liking to do. It makes it a little bit easier. And then once they're gone, we can just use our regular solving rules. But you don't have to. If you're happy to work with the fractions, you can just work with them as usual. So what I like to do is I multiply both sides of the equation by the least common denominator to cancel out the fractions. Okay, so this is what I like to do. And again, the reason it's okay to do that, if you think back to our rules for equations, it's okay to multiply or divide on the same, as long as you do it on both sides of the equation in the same way. So by multiplying both sides by the LCD, I'm not actually changing the solution. This still is okay. So let's start with a simpler example to start. So maybe I have 2/9 x is equal to 4. So here, my least common denominator is just going to be 9 because that's my only denominator, right? If I want to, I could put the 4 over 1, but I don't have to here. So what I do is I multiply both sides by that common denominator. And then I'm going to go ahead and I'm going to simplify. Now, by doing this, you're going to see that you will always get your denominators to cancel out. If they don't, then you've done something wrong. So on the left here, now what you could do is you could multiply first and then rewrite it over 9. But we can also simplify before we multiply here. So I'm going to notice that this 9 over 9 is really just going to cancel out, right? I can divide these both by 9, and I would just get a factor of 1 there. So I'm left with just 2x. On the right here, 9 times 4 is just 36. Now what's going to happen is I have a regular problem. So now you go back to your regular rules. I would divide both sides by 2 here, and I get x is equal to 18 in this case. Now you can still go back and check your answers by going back to the original and plugging that in and making sure it is still true. So if you want to check your problems, go back to that original, plug in your answer, and see if it comes out to be the same value. Now here, again, we can simplify before we multiply. Notice if I divide these each by 9, I get 2 times 2 is 4 over 1, which is definitely 4. So it does check out. So this is the strategy I'm going to use. I'm going to multiply both sides of the equation by a fraction, and I'm just going to multiply throughout. But an easy thing to do is to do that simplifying first here. And instead of running it division like this way, I'm just going to kind of cross things out that are the same. So let's try another example. Maybe I have 3/4 x is equal to 1/2. So here, use all fractions. I have a 4 and a 2, so my LCD is going to be, oh, actually 4, not 8. You could use 8 though. Any common denominator will work. It just makes your numbers a little bit bigger. So we try to stick with the least common denominator. So I multiply both sides by 4. All right, so think about what's going on here. If you want, you can put this over 1 and do your standard multiplication. That's okay too. But notice that 4 over 4 just cancels. So I'm left with 3x. Over here, it's a little bit more complicated, right? So I don't quite get an exact canceling. But if I multiply this straight across, what I see is I will get 4 over 2, which is just 2. So for your multiplication here, you can go straight across and simplify afterwards. Or if you simplify first, that's okay too. You may notice here that, well, 4 divided by 2 is just 2, and I can get the 2 that way. So either is fine. Now I'm going to do a regular problem. Divide both sides by 3, and x is equal to 2/3. All right, I'm just going to do a whole bunch of examples here on this because it helps to see a few of them done out. So let's say I have x plus 1/2 is equal to 5/6. Now again, if you're happy to work with the fractions, you could always subtract 1/2 from both sides using our regular solving rules, but then you're dealing with common denominators later on. So I like to do the common denominators up front here. For 2 and a 6, I could use 6 and cancel everything out. So I'm going to multiply both sides by 6. Now, when you do that, because I have addition here, I do have to use that distributive property. So I'm going to rewrite it. I have 6 times x plus 6 times 1/2 equals 5/6 times 6. Now, 6 times x is just 6x. So I can go ahead and cancel that out, or just multiply that through. Now here, again, you can either simplify first or you can multiply first, whatever works for you. If you want to multiply first, that 6 goes over 1. So you end up with 6 times 1 is 6, and 1 times 2 is 2, so you're going to get a 3 there. Now here, if we have the same number on top and the bottom, it just cancels, so you're left with 5. The other thing you can do here, again, if you notice 6 divided by 2 is just 3, you can get that 3 that way as well, and then 3 times 1 is 3. So you can either simplify and then multiply, or multiply and simplify, but you should have all those fractions disappear. Now, think back to your solving rules. What did we do next? Well, I would bring that 3 to the other side, right, to start getting the x terms by itself. And now I go ahead and I would divide both sides by 6. And I do want to simplify here, so I can divide these both by 2, and I get 1/3 for my final result. All right, let's do another example. How about y over 4 plus 1/4 is equal to -7. So my LCD here is actually just 4. So even though I have the 4 repeated twice, I don't have to multiply it out again. I can just use 4. And I'm going to multiply both sides by 4. Now, if you have a plus or minus, I do need to distribute. So it's going to be 4 times y over 4 plus 4 times 1/4 equals -7 times 4. So what happens here is if you have the same number on top and bottom, it's just going to cancel. So instead of worrying about multiplying through, I'm just going to cancel that out. And I have y plus 1 equals -28. Now I can go ahead and keep solving. So I do want the y by itself, so I want to bring this 1 over. So I'm going to subtract both sides. And I get y equals -29 as my final answer here. So here I have fractions, I have parentheses. Now think about when we had parentheses before, we always cleared that out first, and I actually still like to do the same thing. So even though I want to cancel the fractions, I actually recommend clearing out the parentheses first. So I'm going to go ahead and multiply that 1/2 through. So I have 1/2 times x plus 1/2 times 4 equals 5/3. So this gives me, let's see, 1 times x is x, so I have x over 2. Plus 1 times 4 is 4, so I have 4 over 2 is equal to 5/3. And again, if I need to here, you can always put these over 1 to help you stay organized. Now, I can simplify 4 over 2 to 2. So if you want to do that, you can, but I'm going to cancel the fractions anyway, so I'm not going to worry about it. And I am going to notice that my denominators are 2 and 3. So my LCD is going to be 6 here. So I'm going to multiply both sides by 6. So that means that we end up distributing that 6 throughout everything. Now you can multiply first and then simplify, or you can simplify and then multiply. I'm going to simplify here first. So I notice I have a 6 over 2. Well, 6 divided by 2 is just 3. So 3 times x is 3x. 6 divided by 2 is just 3. 3 times 4 is 12. And 6 divided by 3 is 2. 2 times 5 is 10. Okay, so now I just have a regular problem, and I'm going to go ahead and start solving. So remember, our goal is to get the x by itself. So I want to bring the 12 to the other side in this case. So 3x equals negative 2. I'm going to go ahead and divide both sides by 3 to get that x by itself. Then I have x is equal to negative 2/3. 2/3 is simplified, so I am done here as my final answer. And of course, again, you can always check by plugging those values back into the original problem. I will admit that fraction values are kind of a pain to check, right? Because they do have a lot of multiplying and like terms and things like that you have to deal with, but you can still check them. So you just plug them right back into the original problem, and we can do that. All right, let's do one last example. I'm gonna get a new piece of paper though. All right, here I have denominators of 3 and 4, which is going to be 12 for my least common denominator. So I'm going to go ahead and multiply both sides by 12 here. Again, I don't have any parentheses, which keeps it a little bit easier. And I do want to go ahead and distribute. So I have, let's see, 12 times 2x plus 12 times 1/3 equals 12 times x over 4. Now, 12 times 2 is 24, so I have 24x. I'm going to simplify before I multiply. So 12 divided by 3 is 4, and then 4 times 1 is 4. 12 divided by 4 is 3, and then 3 times x is 3x. Again, I want to keep solving. Now here, don't forget your rules. I have x's on both sides this time, not the numbers. So I want to get the x's together. And I do want the x's to be alone. So if I have x's on the right and the left, but I have numbers on the left, I think what I'll do is bring my x's to the right this time. That way I can keep my 4 on this side and bring my x's to the other side. Now just be careful. It's a positive and a negative, so you're going to subtract, and you have to do it the other way. 24 minus 3 is 21. So we have negative 21x here. And then you're going to go ahead and divide by negative 20. So I get a final answer of x equals, now that negative can go anywhere, so it's only one negative, it doesn't cancel. So negative 4 over 21, and that is simplified. So again, you do want to make sure you check 4 and 21 have no prime numbers or any factors in common. So that would be my final answer. So again, this is my preferred way to deal with fractions is I would still clear parentheses first if I have them. And then my next step is going to be to cancel those fractions and then go back to my regular rules. So if I have x's on one side, I bring them one way, numbers on the other side, kind of keep combining like terms like we have in the past. And the only new step here is trying to cancel those fractions right at the beginning. All right, I just wanted to add one last example here. I just want to talk about this one because it's a little bit different. And we're still going to use the same strategy, but I want you to notice that there are some easy things that you can do first. So if you do see something obvious that you can do, you can go ahead and do that, like 5x minus 4x. That can simplify right away to just x. So if I can clean up a little bit, it is going to still make my life easier. And over here, I have 2 over 11 plus negative 5 over 11. So that becomes negative 3 over 11. Now, if these weren't the same denominator, I probably wouldn't do this because it's going to be too much extra work. But if you have some quick stuff that you can clean up first, you can still go ahead and do that. And then now what I can do is still use that trick of the LCD of 11. So I multiply both sides by 11 here. So I have 11 times x minus 11 times 1 over 11 equals negative 3 over 11 times 11. Here our 11s are going to cancel, so I have a minus 1. And same thing here, they're going to cancel. I have negative 3. And now I can go ahead and keep solving. So I don't want to discourage you. If you do have something quick and easy that you're like, I know I can combine those together pretty fast, you can still go ahead and do that before you use this canceling technique. I do encourage you to always do your parentheses first, though. So that tends to be the biggest help, is to do parentheses first to help you not make mistakes and things like that as well. So I do encourage that here too as you go through. But again, if you see something small that you can do first, we haven't really seen it yet, like 5x minus 4x, that's really easy that you can combine together on that side of the equation. You can still do that first. But I love this little canceling technique for the fractions. Once I get that far, then I don't have to worry about them anymore. So hopefully these examples helped. But of course, if you have questions, never hesitate to reach out.